Is Figure finally about to sell humanoids to everyone? Today on AI News, we're breaking down several game changers at Figure, from a 24x jump in manufacturing throughput to a breakthrough AI system that perceives the world in a new way. We're unpacking three critical layers, starting with manufacturing. So, the transition from functional prototype to scalable fleet is at the valley of death for robotics, but Figure has established BotQ, a high-volume manufacturing facility, to bridge it. This site has transformed from a blueprint into a high-output environment, delivering over 350 third-generation humanoid robots. And most notably, Figure has increased its production rate from 1 Figure 3 per day to 1 per hour, which is a 24 times throughput improvement achieved in under 120 days. And this acceleration is powered by custom manufacturing execution software running across over 150 networked workstations. Furthermore, to solve the dual challenges of yield and cycle time, the company qualified hundreds of suppliers against strict incoming inspection criteria. The assembly line now features over 50 in-process inspection points, and these rigorous quality controls have resulted in an end-of-the-line first-pass yield of over 80%. Specifically, the battery line has achieved a 99.3% first-pass yield across 500 packs, while the facility has produced over 9,000 actuators across 10 distinct SKUs. And before sign-off, each robot undergoes 80 functional verification tests, including burn-in sessions where units perform thousands of squats, presses, and jogs to eliminate early cycle hardware failures. But while 1 robot per hour establishes physical presence, managing a growing fleet of hundreds requires a shift from individual maintenance to autonomous orchestration, and that's where operations come in, because this increased volume of robots serves as a primary data engine for Helix, which is Figure's humanoid AI model. As robots are deployed for research, housework development, and commercial use cases, the influx of real-world data allows the team to harden the systems against failures that are invisible at a smaller scale. And to manage this, Figure has implemented an advanced alert system for rapid failure analysis and engineered software fallback ladders that allow a robot to gracefully degrade its performance or recover from non-critical faults, all without human intervention. And to sustain this growth, Figure developed an internal field service management system and a custom fleet management system. So this infrastructure tracks real-time health, location, as well as operational status of every unit. Plus, it's combined with an over-the-air software update system, so the company can now deploy new behaviors and upgrades to the entire fleet simultaneously. This creates a critical feedback loop. Field failures are analyzed and fed back to the engineering team for hardware revisions, while recall campaigns and upgrades ensure every robot in the field stays current with the latest engineering standards. But with manufacturing and operational infrastructure being this matured, Figure has also unlocked the ability to upgrade the robot's fundamental logic, moving from blind movement to sight-driven action. And this is where perception comes into play, because the latest technological breakthrough for Figure is the advancement of its Helix system S0, which is the AI model responsible for human-like whole-body control. And here's where it gets interesting, because previously, S0 functioned as a blind controller, reasoning only about proprioception and internal joint states. While it could walk on flat ground, it still required hand-tuned mode switches or operator intervention for stairs and ramps. But now, S0 has integrated a transformative capability, meaning that it's fully conditioned on visual camera perception. And here's how it works. RGB imagery is captured by the onboard head cameras and is processed through Figure's stereo model, which projects these 2D frames into a comprehensive 3D representation of the workspace surrounding the robot. This resulting spatial awareness of the scenes is fed to the policy alongside the proprioceptive state, which ensures that S0 no longer merely feels the floor through contact, but actively sees it too. On top of this policy undergoes end-to-end training via reinforcement learning within the simulation environment, where it encounters thousands of randomized terrains. And crucially, the exact network weights that learn to ascend procedurally generated steps in simulation are the same ones that now navigate real-world staircases on the physical hardware. And this transfer is to achieve zero shot, which requires no fine-tuning in physical space. no domain-specific sensor calibration, no human-in-the-loop adjustments, and no failure under varying lighting conditions. Furthermore, in practice, the sim-to-real gap that historically hindered perceptive-driven control is no longer the primary bottleneck for this type of behavior. What S0 masters in simulation is exactly what it executes on the hardware, retaining the same human-like gait and recovery traits that it showed on flat ground. And this represents a pivotal move towards a fully reinforcement learning trained perception condition controller that operates end-to-end across high complexity environments on Figure's humanoid, with stair traversal serving as the initial use case. Plus, the same underlying architecture, perception input, whole body control output, trained in simulation and deployed zero-shot, provides access to a vastly broader category of behaviors where the robot surrounding scene is relevant, meaning that these stairs are simply a proof of concept, but the core capability is entirely general. But this integration of AI into the physical world isn't stopping with just robots, because it's now also infiltrating the very software used to design them. That's because a major shift in digital manufacturing just came into effect with Anthropic's release of a suite of Claude for CAD connectors. This is made possible through a new model context protocol, where Claude AI can now bridge the gap between natural language and professional design environments. So for engineers using Autodesk Fusion, this partnership introduces a true text-to-CAD workflow. Instead of spending hours on manual geometry, users can now describe complex parts or repetitive modeling tasks in plain English, and Claude executes this geometry directly within the software. However, the Blender integration is perhaps the most technically aggressive, because Claude connects directly to Blender's Python API, and it doesn't just answer questions, it also takes action. In fact, users can now use Claude to debug entire scenes, build custom scripts that appear as new tools, or batch apply changes across thousands of objects simultaneously. And while Anthropic is busy embedding AI into the complex world of 3D modeling and CAD, Google is focusing on the final stage of the professional workflow, the paperwork. This is made possible by an efficiency update, as Gemini just gained the ability to generate downloadable, ready-to-share files directly within the chat interface. This means users no longer have to copy and paste brainstorm text into separate applications, but instead, with a single prompt, Gemini can now convert their inputs into a wide range of industry-standard formats, including PDFs, Microsoft Word, and Excel, as well as a full Google Workspace suite of docs, sheets, and slides. Meaning this rollout ensures that their work is ready for immediate download or export to Drive, effectively turning the chatbot into a comprehensive document production engine. Anyways, make sure to click here for more of the latest in AI and robotics news, and thanks for watching.